Getting started with Arduino. When you think of Arduino, what do you really think about? So I'm going to go through 10 slides and we're going to have hands-on and we're going to actually work and be able to light up some LED lights, look at the code. We're a little bit ambitious, but we'll try to do that within this hour. What is Arduino? Is it a circuit board? Is it a brand, a community? Well, it's all of this. And that's what makes Arduino a great starting point for many intelligent projects. As you can see right here, I have the Arduino Uno, which is the most popular one that is out there of a circuit board. But what makes great Arduino is that there's a community of thousands of people around the world that have worked hard to make Arduino easy to work with. Arduino started back in the 2005, now we're 2016, so it has over 10 years of a track record of evolution per se. And not only that, thousands of code has been posted online and you can just find about anything. And that's what makes this great, because if you're starting off and you don't know how to program or you want to see a specific example about code, you can just Google it and you'll find it and you'll see it. Back in the days when there was no internet and people would look code in magazines and in books and they would see others' codes and programming, and that's how they would learn. But now it's at your hands to do it. So Arduino is a circuit board, it's a brand, it's a community throughout the world. Now, who uses Arduino? Right there we have a screenshot of our meetup. We're here in Orlando, Florida / Kissimmee, Central Florida we call it, and we use Arduino. And not only us, but many other people, makers, engineers, entrepreneurs that want to create great products and so forth. Really quick, let me see if I can go to our meetup page and get people acquainted with it. That way, there we go. That way you know how to navigate and how to get started. This is my son Paul, who's going to help us a little bit as we go along. Arduino Electronics, 3D Printing and Entrepreneurship. We're here located in Orlando, Florida, Central Florida, like I mentioned before. So far we have about 185 members. Once you join, just hit join us. If you find us on Meetup anywhere in the world, you'll be able to see our upcoming meetups. This year we have great projects. We're going to start from the ground up. This is an introduction course, and next week we're going to do about just basic electronics. Most people, they want to know about the Arduino board, but they might be lacking skills in the electronics parts. We're going to fill that out. In addition to that, we have great suggestions from some of our members. Some of you that were here last week in our previous meetup, I asked you to give me suggestions. Some of you wanted to have projects and workshops on home automation. That's big right now. Internet of Things. How to make your own toys, your RC robots, RC cars, quad helicopters, and so forth. And we'll be able to do all that stuff. So I would like to ask anybody to join us at the www.meetup.com and sign up, and you'll get all the announcements for everything that we're doing. So going back, who uses Arduino? Entrepreneurs, engineers, makers, anybody, and now it's very accessible to you, to all of us. Where? Around the world. This map right here is out of last year in March. We celebrated Arduino World Day. And as you can see, in America, South America, Africa, Asia, the Middle East, everywhere in the world, there were people participating in Arduino Day. This year, we'll probably also have Arduino Day. And everywhere in the world, awesome things are being created. Why? Because right now, it's much easier than before. I remember taking a microcontroller class at the university. It was one of the most boring classes ever. because there were hardly any hands-on. We were talking about using registers, memory allocation, and from time to time we will blink an LED light. Now with Arduino you can make incredible stuff, robotics. You'll see a video that I'm going to show in a little bit about some of the stuff that people have been making, amazing projects. Why you should learn? Because it's going to make your projects intelligent. Not only they're going to make them intelligent, Arduino is going to help you control and those projects, and you'll get a lot of satisfaction out of making these great projects. How we're going to do it? Well, first, from the ground up, we're going to learn about the basic tools that you can use to make things. And here I have a picture of an Arduino board. Really quick, I'm going to pass, you guys have Arduino boards right here, and those that are watching can see the basic makeup of an Arduino board. I'm going to go over this really quick, not in total detail, but enough that you can understand where to connect and how to do things with an Arduino board. Right in front of me I have an Arduino board that's a genuine Arduino board. There's many different clones, and the big chip that you see right here towards the bottom of the picture, no, I'll try to show it here as well. That is the heart of the Arduino board, the PC board, the Atmega 328 microcontroller. Many people have asked, why didn't they use a different controller from a different company and so forth when they created this back in Italy? Well, some of the reason is because this was a very easy chip to use. And not only was easy to use and implement, but it was also easy to program as well. So around this chip, everything else is being built around. So take a look at your Arduino boards, the ones that you have, and let's go over one by one what we have. Now there's a little bit variations on some of the Arduino boards on where the reset button is. In my particular board, I don't know if you guys can see it, my reset button is on the bottom. On this particular one that I'm showing on the screen, it's right there, not on the bottom, but towards the middle. Let's start from where you plug this board into your computer. I'm going to pretend that nobody knows anything about Arduino right now, and you're just watching live and it's your first time. So when you get the board, first of all, you know it's an Arduino Uno because it's got the name. The version that most people are using is the revised version 3. And what's peculiar about the board itself is that you not only have the components, but you also have headers, which are right here in front, and that's where you put cables to connect things. Let me explain how to use the Arduino board from the computer to the Arduino. The Arduino connects to the computer through a USB cable. Already have this plugged in. And basically, right now, the genuine Arduino is using the same type of USB type of connector that has been used in printers, the big one. But there are other clones, Arduino clones, that use a little smaller USB as well. So I want you to be aware that there's many clones and there are different connectors. So I'm going to focus on just on the regular genuine Arduino. So you get your USB cable and you plug it in there. And then from there, you plug it into your computer, USB. And that's it. You have established a connection. And as you can see right now, there should be an LED light that tells you that there is power and it's on. You basically put in power into the Arduino by connecting it to this USB cable. And at the same time, you're also going to be able to program the Arduino through that cable. That's something very simple to do. Later on, I'm going to go through the programming, and you'll be able to see how to program the Arduino. But at least right now, you'll know, I'll put this right here, how the Arduino is already connected. So let's go back to the screen to see a little bit more details about the Arduino. So we have already plugged in where it says USB plug. We see that the LED light is on, as you can see in this live Arduino. In addition to that, let me point out a couple things. In order for the USB to work directly to your computer, you need this chip right here. And this chip translates the serial information into the Arduino. Many processors require an extra chip to do it if you're just doing it in a breadboard. And I'll explain later what a breadboard is. But in this case, this is what makes the Arduino, one of the items that makes the Arduino very easy to use, because you have this chip that makes an easy connection to your computer. And if I go ahead and close this for a second and open the Arduino IDE, you'll be able to see that there's a connection. So meanwhile this opens, and that's the program that we use to program the Arduino. I'll show you in a second which port are we using in the computer. So let me go back to the picture that I have of the Arduino, and if you have any questions anytime, please let me know. Okay? Okay, so we already have the Arduino IDE on. Here in the Arduino IDE on, when we have it on, we can go to Tools, Port, Serial Port, and here we see COMP3, Communication 6. This port is where my Arduino Uno is plugged in. If I unplug it, look what happens to it. You hear a sound, and then this should go to gray eventually. And then you see the port, it no longer shows the port because it's not connected. So one peculiar thing about this board that is very important is that your computer, your operating system recognizes this immediately, and you can see it when that comes on. Many chips require a little bit more hardware to connect, and it's not as easy. That's something that we have that is awesome. So let's go back to the drawing that we have. So we have the USB plug that we already did, and the computer recognizes that there is an Arduino board thanks to this chip that can connect to the microcontroller. We have a reset button, and that's used to reset the program. In addition, we have all these pins. And let's take a look a little bit of the pins, because you're going to be using cables. And based on the cables that you have and where you connect them, you will build circuits. Here I have a whole bunch of cables. I'm going to use a blue one right here for the moment. But as you can see, with this blue cable, I can plug in to any of these pins. I'm not sure if you guys can see that from where you are. I have plugged in right there for right now, just to show you how easy it is to plug in jumpers, cables all around. Okay. Now that's what makes things easy. You don't have to solder things. In the past, you had to solder things, put them in the breadboard. It was hard to put jumpers and so forth. So these headers make this peculiarly easy to just connect. And if you can look on the sides, right here of this board, and I'm going to get a little bit closer to, you can see that they're labeled all throughout. In the case of what you guys are seeing, you would see that there is a power, ground, and so forth. So I'm going to go over these pins really quick. You can always download a chart in the internet and see the pin configuration, but just to get a general idea, this side of the board we have digital pins, and all of these are digital pins, and you see some squiggly lines right there on pin 3, pin 5, let me see, yeah, pin 6, 9, 10, 11. Those squiggly lines lets you know that those pins, in addition to being just digital pins, they are also pulse width modulation can be connected there. And I'll explain what pulse width modulation is later on, but that's used to dim an LED or to control the speed of a motor. Now, we have these digital pins on this side, and digital pins are basically pins that give you either a voltage of either 0 volts or 5 volts. So it's either 0 off or 5 on. And on this side, we have analog inputs and outputs, analog in this case, I'm sorry, from A0 to A5, and here you can plug in sensors, you can also plug in variable resistors, and you can use this to control a lot of things. Here we have a power line. Here's the 5 volt, 3.3 volt, and ground. This is to connect to other circuits. So in essence, this is basically an input and output type of a board, or I/O. There's new boards that are out there that they're calling I/O, input output, but that's basically what you do. You connect things in and out. Here you have an additional external power supply that allows you to power things when you need more power in your Arduino board. In essence, this is the Arduino board. It's a microcontroller that you have access to all these little pins through these headers, and you can plug things around. I'm gonna stop there for a second just to see if any of you guys have any questions about the Arduino, anything in particular that you would like to know. And also, if you are watching us through Periscope, please type or let us know of any questions that you have, and that way we can answer them before we move on to the next step. We're almost halfway the slides. Let me see what number slide we are here. Real quick. Okay. Yes. We're number 5. So we're halfway there. Any questions from any of the viewers on Periscope?
No.
No?
No.
Okay.
Just asking technical questions about it, but no.
No, okay. If you do have any questions, we'll have an open question later on as well. Let's go ahead and continue and talk about the Arduino add-ons, the awesome projects that people have done. The add-ons are basically things that you can put into the Arduino to make it more capable. Right now we have like a brain, a microcontroller, inputs and outputs, so forth. But what if you can add more things to it to make it more capable? Well, many people did that. The Arduino board is an open source board. They have all the schematics and everything online. You can download and you can build upon the Arduino. Right here, I'm going to put this in front. I have a box filled with shields. Shields are add-ons, circuit boards that you can put into the Arduino, top of the Arduino, and make the Arduino more capable. For example, right here I have a motor control shield, and this shield has pins, and these pins will fit right on top of the Arduino board like that. These pins will go in, and then this suddenly can become a powerful controller of motors. And I'm going to start putting all the Arduino shields right here as we go along, and you guys can see them from there. Let's say I want to send a text message to an Arduino board, through an Arduino project, and through a cell phone network. I can use this shield, which has a chip that will connect to the network on your cell phone. So this, and if you add a couple more things, this could become actually a cell phone. There's another motor control board right here that it's a little bit different configuration than this one right here. That you can control motors, servos, and so forth. We have an SD shield, where if you're doing any type of project where you're gathering that data, you can put an SD shield. This one has for a big SD shield and a smaller one. You can put that on top of the Arduino board. We have Ethernet shield right here. And this Ethernet shield, you can connect it on top of your Arduino board, and then it will become connected to the internet.
I have a question.
Yes.
Once you add a shield, are you only limited to one, or can you add multiple?
You can add several shields, one on top of the other. Some shields have already headers, like this one. This you can plug in, and you already have headers, so you can put something else on top. For example, you could put an SD shield on top of this shield, and then on top of the Arduino. So you could keep building up. This shield that Polly has is a very awesome shield, and we did some projects. Show it to everybody. Thank you, Polly. This is an SD shield, and let's put it right here so they can see it. An SD, I'm sorry, this is a touch, TFT touch shield, where you can control things and you can make games and all kinds of things. And this would display a lot of data. You can use processing. It's another program that you can download and use with this touch screen shield.
I have a question about the shields too. The shields, even the ones with pass-through, like they read right through particular pins, right?
Yes, there are particular pins that the shield works, not because necessarily this has all the pins, it uses all the pins, but particular shields have particular pins that they work on, and you can look at all the specifications, and that way you see if you have conflict between one, because this, for example, could be using a digital pin 10, and the other one could be using digital pin 10, so you gotta be aware of the hardware as well.
Okay, thanks.
Thank you.
Are there like extended pins, additional pin you can add? Are there shields for, you know?
Yes, there are shields. They're very interesting shields that actually, you could call them shields that have the pins that stick out, and then you can actually use screws to plug them in more tightly, or that allows you to plug in something else. Because let's say, for example, I use this Ethernet shield. Unless I solder things here, I won't be able to access these shields. But if you put another set of accessible pins, then I could go in through the side and access those particular pins. So there are many different things that have been created to be able to access things in the shields and so forth. And this one is a very popular sensor. I would call it more of a sensor. It's a ultra range sensor that you can find the distance. And in the case of this sensor, you can use a breadboard. And let me show you a breadboard for those who don't know what a breadboard is. This is a breadboard. We'll go into more detail next week about the breadboard, or possibly today if we need it. But this measures distance by sending an ultrasound, and then you get a return video. In addition to those shields, we have a proto shield, a prototyping shield as well. And this prototyping shield allows you to create your own project, and it comes with headers and all that you can solder. And once you create your own project and parts, you can just put that right on top of your Arduino board. And I haven't even gone to one more shield that I'll show. Actually, a couple more things. Here I have a relay shield, and this would be a shield that you would use to control things. For example, you can connect your bed lamp, and then you can have a timer or a sensor that turns on and off your bed lamp. But this will connect to something that is connected to the wall, 110 volts, and turn it on and off. It's very powerful. You can create a lot of great things with a relay. Relay is basically a switch. You also have a camera shield that you can put right on top of the Arduino board as well. We did a project on this last year, and it was pretty awesome. It was like an alarm. If somebody would come to and pass through a particular area, it would trigger this camera and it would take a picture. So therefore, you will be able to see who the burglar or who invaded your house, your room, and so on. Go ahead.
Question from the audience. They want to know how many items you can connect at one time.
Wow. You can connect as many as you can, as you have the inputs and outputs. In other words, if you fill every single inputs and output here, then you cannot connect anymore. So in the case of the Arduino board, let me go back. I don't know this by heart, but you can connect as many inputs and outputs that you have. So in this case, you have all these pins to connect. So you could connect about literally 13 digital inputs, and you can have about 5 analog inputs as well. So we're talking about 10 to 15, depending what configuration you have, and of different things. But since we are in that subject, if we run out of inputs and outputs, what can we do? Well, we can find a little bit more powerful Arduino board. The Arduino Uno is not the only board. There's tons of many boards that Arduino makes and that have developed. Here I have an Arduino Mega, which is the next best popular, I would say.
Multiplex? I'm just reading the comments, but multiplex?
Oh yes, that is correct. Yes, you can multiplex as well. Multiplexing means getting, in a nutshell, I won't go into detail, is getting an input and creating other inputs or from multiplexing. You're basically getting an input and creating other ones, and then you are you're pretty much dividing that input into other inputs. That is correct. There are multiplexing boards. I worked on an Arduino project. Thank you, Polly. Where they use an Arduino Mega, and they run out of inputs, and they use multiplexing, and that's pretty awesome. This Arduino Mega has tons of inputs and outputs. A lot of large projects we use this. As you can see, I'm going to put them side by side with the Arduino Uno, so you can see how much bigger it is, how many more inputs and outputs there are out there. And these are just two of the Arduino boards that we have. I'm going to pass this on so you guys can see it, those that have not seen it. I also have another, since we're in the subject of boards, I have another Arduino board. This is more geared towards the people that like to control lights and games. This is almost like a controller. You have the buttons right here. They can turn them on and off, and then you have a joystick. And you can put a card, you can put a screen right on top of this. Let me see the shield, the little touch screen. And there's a specific one that they sell, and then you have here like a fader, a variable resistor that you can go back and forth, and you have several sensors. You have a light sensor, you have a little speaker, a microphone. Yep. This is a very interesting board. So you would use something like this. You can create your own game right here and just pretty much play. More like a Game Boy or something like that. So we're going to pass this on. Go ahead and pass it to them, please. So they can see it. Okay. So not only that, but if you want to go into the smaller world, here I have a little LED project that my son was doing, an RGB LED that is being controlled with a smaller board. This is an Arduino Micro. This is a little baby one, and it's pretty nice. As you can see, compared to the Uno, it's pretty small. So if you are making something and you want to make it small and you want to have the power, you can use a Micro. A Micro is a copy of the Arduino Leonardo. The Arduino Leonardo is a different Arduino board, but also you have the Arduino Uno, the smaller one that you can get. But this is just so you can get an idea, and I'll pass this on to you guys so you can see it as well. Thank you, Pauline. Okay, so we have gone over the basic Arduino PC board, some of the parts. We'll get into more detail as we have our next hands-on, which is going to come in a couple of minutes. Let's talk a little bit about the shields. You've seen all the shields that I mentioned. Let's look over a little bit about the shield list. If you go online, you'll see shield lists, and I'm not sure if this is the most updated one, but you have tons of different shields. The ones that I've shown you here are just a little bit of all of the ones that are available that you can expand. You see this example of how they stack together all these shields? That is kind of crazy. But there it is. All the shields made by all these companies. Some are considered official shields, some are just shields that other people sell and so forth, and you can go and look at the shields, and depending on your project, you can buy a shield. Or you can make also, there's a shield that actually you can make a shield, kits as well. So, as you can see, the Arduino platform is an incredible developmental, I would say, tool for anyone, because you have all these electronics that have been fabricated by many, many different companies. So let's take a look at some of the other things that you can get. You can get whole vast amounts of kits that are available, like this Arduino kit, for example. You have the board, you have a prototyping shield that goes on top of that board, then you have a relay, you have a joystick right here. It's the same thing as what we have. This range finder, distance sensor, ultra range, power. It comes with the headers, pins, RGB LED lights, LCD, and so forth. And really quick, I just want to show you a quick implementation of one of the projects that we did here. And I'm going to go ahead and move all these shields really quick. And I'm going to show you a weather station that we created on one of our meetups. And this weather station is pretty interesting because it uses sensors, and this is a whole implementation of it. It uses sensors, and you're able to see 4 things: temperature, pressure, humidity, and altitude. And the cool thing about it is that many people are into sensors, and you'll be able to control your environment, know exactly what's happening, and so forth. That comes from this very tiny sensor right here. This is a different breakout board for Wi-Fi. We have not implemented that part yet. But I want to get you an idea of some of the stuff that you can create with some of your projects. Let me see if I can power this. Okay. We have powered this, and right now, hopefully some of you can see, we have the temperature right there on that screen. It's telling us is 74.61 degrees, humidity 39.61, pressure, and then altitude. See if you guys can see that. All this implemented through an Arduino board and sensors. The next thing we're going to try to do this year to expand our weather station is to include one more factor, which is going to be able to read what's in the air. In other words, we'll be able to see if there's any carbon monoxide or any other type of pollutants. So I'll have this on here so anybody can see. It's a little weather station that we built.
What kind of tolerance does that have for particulate matter? How accurate is it, the one you're talking about?
Oh, they have not released the chip yet, but as soon as they release the chip, I'll be able to give you more details about that. But this particular one, made by Bosch, right here, the sensor is actually this little tiny puny thing right here. You can measure those 4 things, and everything else around, it helps get the information from that little sensor, the breakout board. Okay, let's go ahead and continue this, and then we're going to have an actual hands-on. But before we do that, let's talk about some of the awesome projects that people have done. Here I have a video that you guys can see on YouTube, and I'm going to play a little bit of it. The founder of Arduino will talk about what's been done.
A few weeks ago, a friend of mine gave this toy car to his 8-year-old son, but instead of going into a store and buy one like we do normally, he went to this website and he downloaded the file and then he printed it on this printer. So So this idea that you can manufacture objects digitally using these machines is something that The Economist magazine defined as the third industrial revolution. Actually, I argue that there is another revolution going on, and it's the one that has to do with open source hardware and the makers movement. Because the printer that my friend used to print a toy is actually open source. So you go to the same website, you can download all the files that you need in order to make that printer. The construction files, the hardware, the software, all the instructions is there. And also, this is part of a large community where there are thousands of people around the world that are actually making these kind of printers, and there's a lot of innovation happening because it's all open source. You don't need anybody's permission to create something great. And that space is like, you know, the personal computer in 1976, like the Apples with the other companies are fighting, and we will see in a few years there will be the Apple, this kind of market come up. Well, there's also another interesting thing that I said the electronics is open source because at the heart of this printer there is something I really attached to, this Arduino board. So the motherboard that sort of powers this printer is a project I've been working on for the past 7 years. It's an open source project. I work with these friends of mine that I have here. So the 5 of us, 2 Americans, 2 Italians, and a Spaniard, it's a worldwide project. So we came together in this design institute called the Interaction Design Institute, REA, which was teaching interaction design, this idea that you can take design from the simple shape of an object and you can move it forward to design the way you interact with things. Well, when you design an object that's supposed to interact with a human being, if you make a foam model of a mobile phone, it doesn't make any sense. You have to have something that actually interacts with people. So we worked on Arduino and a lot of other projects there to create platforms that would be simple for our students to use, so that our students could just build things that work, but they don't have 5 years to become an electronics engineer. We have 1 month. So how do I make something that even a kid can use? And actually, with Arduino, we have kids like Sylvia that you see here that actually makes projects with Arduino. I have 11-year-old kids stop me and show me like stuff they built for Arduino. That's really scary to see the capabilities that kids have when you give them the tools. So let's look at what happens when you make a tool that anybody can just pick up and build something quickly. So one of the examples that I like to sort of kick off this discussion is this example of this cat feeder. The gentleman who made this project had 2 cats. One was sick and the other one was healthy. So he had to make sure they ate the proper food. So he made this thing that recognizes the cat from a chip mounted sort of on the collar of the cat and opens the door and the cat can eat the food. This is made by recycling an old CD player that you can get from an old computer, some cardboard, tape, a couple of sensors, a few blinking LEDs, and then suddenly you have a tool. You build something that you cannot find on the market. And, you know, I like this phrase, scratch your own itch. If you have an idea, you just go and you make it. This is the equivalent of sketching on paper done with electronics. So one of the features that I think is important about our work is that our hardware, on top of being made with love in Italy, as you can see from the sort of back of the circuit, is that it's open. So we publish all the design files for the circuit online. So you can download it and you can actually use it to make something or to modify, to learn. You know, when I was learning about programming, I learned by looking at other people's code or looking at other people's circuits on magazines. And this is a good way to learn by looking at other people's work. So the different elements of the project are all open. So the hardware is released with a Creative Commons license. So, you know, I like this idea that hardware becomes like a piece of culture that you share and you build upon, like it was a song or a poem, you know, with Creative Commons. Or the software is GPL, so it's open source as well. The documentation and the hands-on teaching methodology is also open source and released as the Creative Commons. Just the name is protected so that we can make sure that we can tell people what is Arduino and what isn't. And Arduino itself is made of a lot of different open source components that maybe individually are hard to use for like a 12-year-old kid. But so Arduino wraps everything together into a mashup of open source technologies where we try to give them the best user experience to get something done quickly. So you have situations like this where Some people in Chile decided to make their own boards instead of buying them to organize a workshop and to save money. Or there are companies that make their own variations of Arduino that fit in a certain market, and there's probably maybe like 150 of them or something at the moment. This one is made by a company called Adafruit, which is run by this woman called Limor Fried, also known as Lady Ada, who is one of the heroes of the open source hardware movement and the maker movement. So this idea that you have a new sort of turbocharged DIY community that believes in open source, in collaboration, collaborates online, collaborates in different spaces. There is this magazine called Make that sort of gathered all these people and sort of put them together as a community. And you see like very technical project explained in a very simple language, beautifully typeset. Or you have websites like this one, like Instructables, where people actually teach each other about anything. So this one is about Arduino projects, the page you see on the screen, but effectively here you can learn how to make a cake and anything else. So let's look at some projects. So this one is a quadcopter. It's a small model helicopter. In a way, it's a toy, you know? And so this one was military technology a few years ago. And now it's open source, easy to use, you can buy it online. DIY Drones is the community, they do this thing called Arducopter. But then somebody actually launched this startup called Matternet, where they figured out that you could use these to actually transport things from one village to another in Africa. And the fact that this was easy to find, open source, easy to hack, enabled them to prototype their company really quickly. Or other projects.
I'm getting a little sick of hearing about the same people on TV over and over and over again, so I decided to do something about it. This Arduino project, which I call the Enough Already, will mute the TV anytime any of these overexposed personalities is mentioned. I'll show you how it goes. Our producers called Kim Kardashian earlier today to find out what she was planning on wearing during. It should do a pretty good job of protecting our ears from having to hear about the details of Kim Kardashian's wedding.
Okay, so, you know, again, what is interesting here is that Matt found this module that lets Arduino process the TV signals. He found some code written by somebody else that generates infrared signals for the TV, put it together and created this great project. It's also used, Arduino is used in serious places, like, you know, the Large Hadron Collider. There's some Arduino boards collecting data and sort of measure some parameters. Or it's used for this is a musical interface built by a student from Italy, and he's now turning this into a program because it was a student project to become a program. Or you can use to make assistive device. This is a glove that understands the sign language and transforms the gestures that you make into sounds and writes the words that you're signing on the display. And again, this is made of all different parts. You can find on all the websites that sell Arduino compatible parts, and you assemble it into a project. Or this is a project from the IDP part of NYU, where they met with this boy with severe disability, cannot play with the PS3, so they built this device that allows the kids to play baseball, although he has limited movement capability. Or you can find it in arts projects. So this is the TXT bomber. So you put a message into this device, and then you roll it on the wall, and it basically has all these solenoids pressing the buttons on sprite cans. So you just pull it over a wall and it just writes on the wall all the political messages. So then we have this plant here. This is called Botanicals, because this is there's an Arduino board with a Wi-Fi module in the plant, and it's measuring the well-being of the plant, and it's creating a Twitter account where you can actually interact with the plant. So, you know, this plant will start to say, this is really hot, or like, there's a lot of, you know, that I need water right now. So it just gives a personality to your plant. Or this is something that twitters when the baby inside the belly of a pregnant woman kicks. Or this is a 14-year-old kid in Chile who made a system that detects earthquakes and publishes on Twitter. He has 280,000 followers. He's 14, and he anticipated a governmental project by 1 year. And, or Again, another project where by analyzing the Twitter feed of a family, you can basically point where they are, like in the Harry Potter movie. So you can find out everything about this project on the website. Or somebody made a chair that twitters when somebody farts. So it's interesting how in 2009, Gizmodo basically said that this project actually gives a meaning to Twitter. So it was a lot changed in between. So very serious projects. When the Fukushima disaster happened, a bunch of people in Japan, they realized that the information that the government was giving wasn't really sort of open and really reliable. So they built this Geiger counter plus Arduino plus network interface. They made 100 of them and gave them to people around Japan. And essentially the data that they gather gets published on this website called COSM, another website they built. So you can actually get reliable, real-time information from the field, and you can get unbiased information. Or this machine here is from the DIY bio movement, and it's one of the steps that you need in order to process DNA. And again, it's completely open source from the ground up. Or you have students in developing countries making replicas of scientific instruments that cost a lot of money to make. Actually, they just build them themselves for our class using Arduino and a few parts. This is a PH program. Or you get kids, like these kids, they're from Spain, they learn how to program and to make robots when they were probably like 11, and then they started to use Arduino to make these robots that play football. They became world champions by making an Arduino-based robot. And so when we had to make our own educational robot, we just went to them and said, you design it, because you know exactly what it's needed to make a great robot that excites kids, not me, like I'm an old guy, what am I supposed to excite? No? But it's like, in terms of educational lessons. There's also companies like Google that are using the technology to create interfaces between mobile phones, tablets, and the real world. So the accessory development kit from Google is open source and based on Arduino, as opposed to the one from Apple, which is closed source, NDA, sign your life to Apple. Here you are. There's a giant maze, and Joe is sitting there, and the maze is moving when you tilt the tablet. Also, I come from Italy, and design is important in Italy, and yet very conservative. So we worked with a design studio called Habits in Milan to make this mirror, which is completely open source. This doubles also as an iPod speaker. So the idea is that the hardware, the software, the design of the object, the fabrication, everything about this project is open source, and you can make it yourself. So we want other designers to pick this up and learn how to make great devices, to learn how to make interactive products by starting from something real. But when you have this idea, what happens to all these ideas? There's like thousands of ideas that it would take 7 hours for the presentation. I will not take all the 7 hours. Thank you. So, but let's start from this example. So the group of people that started this company called Pebble, they prototyped a watch that communicates via Bluetooth with your phone, and you can display information on it. And they prototyped with an old LCD screen from a Nokia mobile phone and an Arduino. And then when they had a final project, they actually went to Kickstarter, and they were asking for $100,000 to make a few of them to sell. They got $10 million. They got a completely fully funded startup, and they don't have to, get VCs involved or anything, just excited people with their great project. The last project I want to show you is this. It's called Ardusat. It's currently on Kickstarter, so if you want to contribute, please do it. It's a satellite that goes into space, which is probably the least open source thing you can imagine. And it contains an Arduino connected to a bunch of sensors. So if you know how to use Arduino, you can actually upload your experiments into this satellite and run them. So imagine if you as a high school can have the satellite for a week and do satellite, space experiments like that. So, as I said, there's lots of examples. So I'm going to stop here, and I just want to thank the Arduino community for being the best, and just every day making lots of projects. Thank you.
Excellent. Hope you guys enjoyed that video. Now, can anyone tell me how old is that video?
3 years.
How many?
3 years.
At least 3 to 5 years, if not more. I think it's 2012. 2009 they mentioned, 8, 9, 10, 11. It's at least 5 to 6 years old. So imagine all the other possibilities and all the other projects that have been created since then Some of you might be surprised, like, oh, that'll be awesome to make that, you know. But that's stuff that's been made already about 5 years ago or 6 years ago. I haven't even shown you some of the projects that are there. I'm gonna leave that to you to go ahead and Google and check out any other projects that are out there that are even more advanced than what you have seen.
The audience is saying thank you for the video.
Oh, you're welcome. I hope you guys were able to see it and you saw a good quality and sound. Thanks to Robin for being an awesome camera producer. Okay, let's talk a little bit about the Arduino IDE, which is the program that we use here when we want to program our Arduino. This is a little drawing that shows you some of the things on your Arduino IDE. You guys that are here live and you're at home, go ahead and open your Arduino program, please, and take a look on how it looks. And we're going to go over very quickly on the different parts. And right after this, we're going to actually connect our Arduino board, and we're going to use the IDE here live. So, when you open your Arduino IDE, the IDE stands for the development, the environment, that in other words, the program that is used. You could call it the app, but that's the new, more popular term for the program that runs the Arduino that you use to program. If you look on top, you have all these buttons that makes it look very, very simple. You have, once you write the code in this area, which is called the editor area, you would hit the verify sketch, and then any error will show up right here on the bottom if you have not programmed this correctly. And then you have another button that will compile and upload the program, and it will go out of your USB into the Arduino board. So this is the program this is the button that sends the program into the Arduino board once you have programmed. And then you have new sketch and then open sketch if you're looking for a program. Sketch is the name that Arduino has given the name for your code, for your program. So this right here is a sketch. You normally think of the word sketch to be a drawing or some kind of a design. And the reason it's called sketch is because the Arduino IDE actually it was borrowed from another program called processing. Processing is a powerful program that you code in C, the language of C, as well, and you can do graphics, and it's used by a lot of artists and so forth to interact as well with electronics and make interactive things. So the Arduino IDE comes from the evolution of the processing. And back in the days when the program processing used their IDE, this program, they called it Sketch, and that kept on. So that's why it's called Sketch. So when someone says, I just wrote a sketch on Arduino, it means I coded a program, in other words. And then you can save it as well. This button is very easy. This particular button right here is a serial monitor. When you press that button, you can see your actual output of the Arduino board in your screen. And it's very important, and we'll go over that later on as we do more workshops. Right here is where you write your code. And if you have any errors, it will show right here. Right at the bottom, it will tell you where your cursor is and what particular line and number and so forth. So that's the basic anatomy of the Arduino IDE. Now I'm going to actually open it, and we're going to go over, because we still have a menu on top right here that's not showing on this particular picture. And as I open my Arduino IDE, now there's different versions of the Arduino program. The one that I favor is the one that you can download from www.arduino.cc, which was shown at the beginning, and we'll go over that website in a little bit. But this is the Arduino program that you use. Right here you have file, edit, sketch tools, and so forth. So in order for us to do our first program, let's have everybody connect their Arduino boards to their computer, open up the Arduino IDE, and then when you open it, you'll have this screen. If you have a newer version, you'll have some data here. It says voice setup, put your setup code here, run once. If you have the older versions, this will be blank. There will be nothing here. So they're making it easy as they do more versions to program. So let's go ahead and do the first example, and this is going to be our first hands-on. After you plug in your Arduino board, go to File. Before you do that, let's double check that your computer has recognized your Arduino board. So go to Tools, Port, and look on port if you have your Arduino Uno connected. In this case, I have it to COM6, and this is in black, it's not in gray. So I'm going to go ahead and click on that. When I have clicked it, now if you look, it shows that I have a marking here, and it shows that my Arduino board is connected to port 6. If you're using an Apple, it will be seen a little bit differently. Then after that, you know you have a connection. Go to File, go to Examples, and then we're going to go up to Basics, and we're going to go to Blink, and then click it. When we do that, you'll get another screen that will open up. This is the basic programming example on how to blink your LED light in here. The Arduino board has something very peculiar, that on pin 13 you have an LED light that you can blink. And I have my finger right there on pin 13. And right now there's a steady light right there. And we'll be able to go ahead and blink that light once we program the Arduino. So we have a built-in LED, we don't have to connect anything. We'll go ahead and do that as our first example or sketch. So for those that are out there, do you have any questions so far that are listening or looking through the broadcast, or anyone here? Have all of you been able to open your IDE and open that particular file? Okay. Any questions that you see, Robin? No? Okay.
One comment is that, I don't have it to the electrostatic,
Oh, yes.
this
That is correct.
just
Thank you for pointing that out.
happen.
I know you're an electrical engineer and you probably worked in industry. Usually when you're doing working with circuits, you have a static on your body, and if you touch electronics, you can blow some of the electronics. And in industry, you usually have a electrostatic mat that you put underneath, and then you ground yourself to that table or to that mat. That way you don't put any static electricity, that way you don't blow your circuits or your transistors and so forth. We're being very, I would say, plain and wild to just do it this way, but the Arduino boards are built so well that I think I have never blown it just by touching it or using it. However, if you have a conductive surface underneath, and you just put your Arduino board, what have you done? You have shortened all these pins and you will blow your Arduino. So I would suggest that wherever you put your Arduino, or you can have standoffs like I have right here, you make sure that there's nothing conductive underneath, otherwise you're going to short some pins and you're going to blow your Arduino board. Thank you for pointing that out.
That's a good point.
Yes. Sometimes we take things for granted and we just do them and so forth. Now the good thing about this particular Arduino board is if you end up blowing the chip is on a socket. You can just pull it out and then buy another and put it in. But if you use the surface mount type of clones, once this blows, it will be really hard to go ahead and replace that unless you really know how to solder surface mount, and that's a little bit difficult. It takes some skill set. So having said that, let's go ahead and look over the sketch really quick and see what's happening there. Here at the beginning, from this point to this point that I have highlighted in yellow, can you guys see in the screen? Okay, these are comments. And the comments usually in the code are done with a slash asterisk if they're long and more than one line. So these are comments. This is not going into the program. It's just giving you some information about what this program is about, where you can find more information, what it does, and so forth. So in essence, and this is another comment, but you see these two slashes right here at the beginning? These two slashes allows you to put this comment, so it's not counted in the program, it's not as a program part, but the two slashes is only when you do one line. If you go more than one line, you gotta use the slash asterisk and then slash asterisk, the backslash, to be able to do more than one line. So right now, for example, I can just go there and then just put two slashes and just say, this is my first sketch. So that would not count in my program. It would just be information that you put in there. And you can also comment in the back of a command and so forth. For example, right here, down here you see where it says digital write 13 high. Here it tells you there's a comment that gives you information what's happening there. It's very important that you comment your program, that way others that can read it can understand what your program is doing and so forth. So right here, the real part of the program, I'm gonna delete all this so we don't get confused, and in essence, this is the heart of the program that's going to blink that LED light. As you can see, there are two parts in here, and I'm going to separate them so you guys can see it. Most Arduino programs have two parts. Have a voice setup part, which starts with this bracket and ends with this bracket. And I'm going to go ahead and delete that comment. So this starts with voice setup all the way up to here. This is one part of the Arduino program. Every Arduino program has this voice setup. This is the setup of your hardware that you'll be using. So right here on pin mode, we're setting pin 13, which is right here on the board. We're setting that pin to be an output. That's what this line is doing. Pin mode 13, output. So we're just saying output on pin 13, but in this case, pin 13 already has a built-in LED that we're going to light up. So when we say pin mode 13 output, we're telling the Arduino board send 5 volts to pin 13. And by doing that, it's going to light up that LED. That LED has also a resistor that keeps the current. So if you just put 5 volts directly to an LED, you will blow it. You need to have a current limiting resistor that's already built in there. So this setup is setting that pin 13 to be an output. And then this is the second part of the program. And what we're doing is a digital write with this function. We're setting pin 13 to be high. In other words, we're saying to turn on the LED, we're setting the voltage. This one is just telling the processor to make it an output. Why? Because the cool thing about the Arduino is that you can make either input or output out of the pins, and you gotta declare it, you gotta let it know what it is. And then we have a delay of 1,000 microseconds. 1,000 microseconds is 1 second, so there's a 1 second delay. And then we're gonna turn off the light by putting low. So this is saying send voltage, wait 1 second, turn off the voltage, wait 1 second. That's going to create the blinking LED. So let's go ahead and do it. First, let's verify by hitting this button right here, the check. As you can see on the right side of the IDE, we have this little status bar, and it's checking if what we wrote is correct. You guys go ahead and do that right here, and at home, the ones that you're at Periscope or you're following us. And now you have some message here. It says done compiling. That means it checked the code, it verifies it's being good. That feels awesome. If you have an error, you'll have an error and it will show you the error. Here it tells you the memory and so forth. So far we have checked the code. Now by hitting this button, we're going to upload the code. And as soon as we do that, you see these lights blinking? Those lights blinking tells you that the code has been transferred to the Arduino board. And if you do that, you will have a blinking LED light, as you can see right there. Success. You have done it. You have, all of you guys have been able to accomplish that? Very simple, right? Okay. It's blinking on and off, so forth. So you have controlled that little light in there, on and off, on and off. Okay. So let's modify this code now and see if we can make this blink a little bit faster. What can we do to make this blink a little bit faster in this code?
Delay.
The delay. We can change the delay. Okay, let's change it to what? 500? Let's go out, say 500, which is half of a second. Instead of every second on, off, I'm going to change both of the delays to 500 milliseconds. I'm going to go ahead and verify right away. I'm going to upload it, and it's being uploaded, and it's done uploading. Now look at that. Look at the blinking LED light. We have done it so that it turns on and off every half of a second. All right. Let's do it faster. Let's do it 100. Let's put 100 right there instead of 500. And see if we can still see a blinking LED light. If our eye is fast enough. We're going to verify. We're going to check it. Program has uploaded. Look at that light. It's blinking really, really fast. Pretty cool. Any questions so far, you guys? If you're watching,
You're laughing out loud.
pretty nice. But for some of you, this might be okay. So nice. I'm making an LED light blink inside the board. I haven't done really much. Well, now we're gonna take it outside the board. We're gonna make it so that we can blink an actual LED light. And here I have a whole bunch of LED lights, and I'm gonna have my son pass them to you guys here. And if you have any LED lights at home, go ahead and get them. Let's pass this. I'm gonna grab the red one so that I can use it. Okay. And I'm gonna go to a slide really quick on my presentation so that way I can show you a little bit more details on the RGB LED. This is the hands-on part slide. So let's go ahead and let there be light. Let's turn on this light. Let me explain a little bit of how LED lights work. Here at my hand I have a small red RGB LED light. What I want you to see about this is that you have two legs, one here and another one there. One is bigger than the other, and I'm going to separate them so you guys can see them a little bit. There's the big one, there's the small one. And then if you feel on the side of the LED, you'll find a flat area. You can tell which one is the anode and the cathode by the flat. Where the flat area is, on the side, is the cathode. And the round side is the anode. Hopefully you guys can see it. I'm going to zoom in a little bit. And this is what the LED looks from top, from a profile. And that's the schematic diagram symbol for it. So what we're going to do is we're going to use this LED and connect. But if we connect directly, there will be too much current and it will blow this LED. So we have to use some kind of a electric device to limit the current. And for that we're going to use a resistor. So right here in front of me, I have a resistor. It's about 220 ohm resistor. Let me take a look at something a little bit better than that. I'm going to pass that on to you guys, and I'm going to show you how to connect that with the breadboard. Okay. Right now, we're not going to be concerned about the value of the resistor and figuring out what value we need. We're just going to use these resistors. Next week, we're going to go over on what calculations you need to do. So I'm going to pass this on to you guys. We have some resistors right here. And you have an RGB, an LED light. Please pass on to all of you and pick up some LED lights. We're going to be able to do that. The other thing you will need is a breadboard. And that way you can put your LED in there. Let me explain really quick what a breadboard is. A breadboard, the reason it's called bread is because it's porous, just like a slice of bread. And the way you do it is you can insert the legs of electronics. Now this circuit is separate from this circuit, so you can connect things across and you'll be able to connect that way. So what I'm doing is I'm going to put this LED between these two openings on the breadboard, and I'm gonna just make sure that I know which of the legs is my long leg, and I made a little knee to know that the one ahead is the one that is the longest. In this case, the anode. And what I have done is I'm putting this in the breadboard at two different lines. If you guys need to borrow breadboard, let me know. I have extra ones here. You need any? Okay, good. All right. So I have put one leg on one side and then the other one on the other side. Now I'm going to connect the resistor on the leg that's the longest, and I'm going to put that to the red line. I don't know if you guys can see that at home. Let's get a little bit closer right here. Okay. And what I've done is, in essence, I have connected this leg through this line, through the resistor, to this red power line. And now I'm going to use a cable. I'm going to use this orange cable to signify for the power. You can use red. It would be preferably if you use red if you have one. And now I'm also going to use this white cable to connect the smaller leg to ground. In this case, I can just go directly to the Arduino board, and you can see next to the 5 volts is ground. G and D. See if we can get a little bit of a close-up right there. Right here to ground. So the smaller leg is connected to ground, and the big leg will actually be connected directly to one of the digital pins. Sorry, I had it connected to power. It's going to be connected directly to the digital pins. So the way I'm going to do it so it can reach, I'm going to put it into this other side, and from here I'm going to connect to one of the pins. We used 13 already. You guys pick a pin in the digital that you would like to be connected. Take a look at your boards and which pin of this you think you would like to connect. Let's try number 7. So I'm going directly to pin 7. So I'm going to go to the board right here and show you a diagram of what I have done. have done, this is the Arduino board. And in the Arduino board, I'm going to locate that on this side right here, this is your connection to the USB on your computer. USB. Here's a little barrel connector where you can connect power as well. And here's where the chip is. And right here are the two. You have one and then two headers, and then you have two other ones right here. Let me take a look here. Yeah, right here on the bottom, you have another set of headers as well. So what I'm doing right now is I'm connecting ground. On this side you have ground, G and D. Right there, and I'm connecting that, and I'm going to do an LED here, picture a small LED or a big one, so you guys can see it. And how I have the two legs. I have one leg, which is the long leg, and I have the smaller leg right here. Smaller leg is connected to ground. So for the connection, I'm going to use green so you guys can see it. This is connected to ground, G and D. And then I'm skipping right here the breadboard, just showing you the actual physical connection without the breadboard. And then the positive, I'm going to connect it to pin 7, which is on the other side. So pin 7 is right here. So that's connected to pin 7. And that would be the positive, but we cannot just connect it right away. We've got to put a resistor to limit the current. So right here we have a resistor. This is the symbol for a resistor that we have done. When we do that, when we change the code to pin 7, to make this a little bit bigger, instead of 13, what we have done in essence is turned on, send the voltage to pin 7, and then what will happen is this LED, in this case we have a red one, will go ahead and shine, will turn on. We're using the breadboard, meanwhile, in our example, because it's easier to connect, but you could just connect this directly into the board as well. So let's go ahead and do that. I have everything done there. Hope you guys can see it. Okay. And we'll have more details and schematics and so forth. Have all of you guys been able to do it? Look at that. It's already blinking. You already done it. You're ready to go. How about you guys?
Yeah, I just had to work a couple of minutes ago.
Excellent. You guys are way ahead. Can you show a little bit of what they've done so they can see?
I changed the code a little bit so it blinks fast and slow. So this will be a little different from what people have at home. So it blinks fast for a while and then it blinks slow. So it's
very, very nice. And how about you?
We just changed all of them.
Yeah.
All of them to 7 on the ID.
You changed some of the stuff in the ID?
I'm asking.
Oh, okay. Yes, let's go over the ID. Some of you guys are way ahead. You've already done it, but let's go ahead and... So what I would do is I'll go ahead and open up again the same ID that we had before. Let me see if I have it right here. Here we go. This is the ID. Instead of being pin mode 13, that's an output, it's going to be number 7. Because that's the thing that we have connected into our board. And then instead of digital write 13, it's going to be 7. Digital write 13 for low, it's going to be 7. That's the pin that we have just picked. Okay, can all of you guys see that? I'm going to go ahead and make this go a little bit less. So what we have done in essence is we have changed, instead of being pin 13, we have used an outside pin to use as the output, pin 7. Okay, let's go ahead and check real quick. It checks out, there's no problems. Look at that, she already has it. Can you show her result? Wow, that's pretty cool, right? Very nice. So, let me go ahead and upload it and see. There it is. Mine's blinking, not as bright as yours. It depends on what resistors we are using. Excellent. Very good.
Another question.
Yes.
Is there a place that you can go to see where all the different functions are, like digital rise and delay?
Excellent question. In the internet, you can go to the Arduino, and let's go ahead and go there real quick. Right here we can go Arduino.cc. That's the official Arduino webpage. And when you go to the Arduino webpage, you have incredible resources. Here under Learning, you have tutorials reference. Let's look at the reference. The reference gives you a guide to all of the different structures, variables, functions that you can use to write code. So if you ever want to do something and know how do I use the if statement, if you have already coded in the past, you can just go ahead and do that. How do I do the setup, the loop? And he explains to you in detail about everything. What did we use today? We use pin mode right here to set up our pin mode as either output or input. Let's take a look at that. Here it tells you what the pin mode function does, how to use it, the input, output. That's exactly what we did. And the beauty right here is a sample code. See, the same exact thing that we did actually is right here. This is the example, the blinking LED that we did. So very easy to find the information. And again, it's www.arduino.cc, and then you go to Learning, Reference. In addition to that, there's tons of YouTube videos as well, and so forth. Okay, we're almost at the end of our broadcast, and congratulations to everybody.
Actually, I got a question too.
Yes.
Instead of a resistor, could you just use the analog output and just give it a lower number?
That is correct. You could use the analog to control the brightness, but you still need that resistor there to control the current. But the analog input, you can use it with a pot, with a little variable resistor, and later we'll be able to make it either brighter or dimmer. That is correct.
So it can't become a resistor, but it'll change the brightness stuff.
Oh, you're talking about instead of this one?
Right. Like
you could do that, but it's not really going to change the brightness with just moving it with a variable resistor. It'll change your current. It would change. Let me say that it would change your brightness, but it would not be the most efficient way of changing your brightness by using a variable resistor right here instead of this one. Because if you do that, you'll be just changing the current, and then what happens when you're changing current with a variable resistor, you're actually losing a lot of the power. You'll be if you're using a battery to power this, you'll be taking a lot of the current from the battery, and your battery will not last as long. A better way of making this LED to be brighter or less bright is to use a variable resistor on the other end, right here on the analog, and use pulse width modulation, which is the next thing we're going to try to do next week. Okay. Instead of using a variable resistor to dim it or not, we're going to use pulses to turn on brighter or to turn on the LED either faster or slower.
Is there an Arduino simulator for virtual prototyping?
There is. I don't know the exact name. There's several of them that you can do virtual prototyping, and I'll go ahead and put that in the meetup today, and then that way you can go ahead and log into that. There's tons of tools that we can use. Go ahead.
I had a question from earlier. When you do the nodes with the double backslash, how does it know when your node ends and where the coding?
Okay, thank you very much for asking that. If we take a look at our earlier example right here, under the basic, and we go to the blink, we have for the comments, for putting the communication, we have a slash asterisk. It knows it ends because you have an asterisk and the other side of the slash, the backslash. That's how it knows. Let me go ahead and open that again and see if we can see it there under examples, basic, click. Okay. It's not opening right at the moment, but basically anything you want to comment, there's more than one line, you would use the asterisk slash, and then you will have the opposite on the other side as well. Let's go ahead and finish the last slides. I think we're almost done pretty much here today. Yes, we are. So we had 10 slides. We had a hands-on, turning on the blinking LED. We went over a lot of information. Some of you might be difficult to grasp it in one session. As much as you continue doing this and practicing, you'll be able to get better and you'll be able to make incredible projects. If you have any questions, please go to our meetup page at Arduino Electronics 3D Printing and put any comments and let us know how you feel, how was the broadcast today, and by you doing that, you'll enable us to make this much better, and not only will be able to help you and answer questions, but hopefully will inspire you to keep learning about electronics, Arduino, and 3D printing. Thank you everyone for coming tonight and for being there, and we'll see you next week when we'll do a little bit more of the electronics. We'll do the calculations of the what it takes for this resistor, what exact value we need to turn on this this LED, and we'll use RGB, red, blue, and green LEDs, and we'll be able to change it to almost any colors. There's going to be something beautiful. Thank you. Have a wonderful day, and we'll see you next week.